f of z is equal to u as a function of x and y plus iv, which is function of x and y, is an analytic function of complex variable z is equal to x plus iota y, where iota is square root of -1. If u is equal to 2xy, then we need to find the expression of v, which is a function of x and y. Now, since the function is complex analytic, it follows Cauchy-Riemann's equation. So let's write here Cauchy-Riemann equation. Now, according to Cauchy-Riemann equation, the partial derivative of the real part of this function f of z, which is u, with respect to x will be equal to partial derivative of the imaginary part of this equation v with respect to y, and dou u by dou y is equal to negative of dou v by dou x. One thing to notice here is u and v both are real, okay, but when we multiply v with iota, then it becomes imaginary and the whole function becomes complex function. Okay, so let's use this Cauchy-Riemann's equation to find the value of v here. So u in the problem, it's given 2xy and we need to find v. So if we consider this first Cauchy-Riemann equation, so from here we can write dou u by dou x, this will be equal to 2y, which is equal to dou v by dou y. Therefore, if we integrate this equation, so we can write v is equal to integral 2y dy. Okay, so again v will be equal to 2y square by 2 plus a constant, and the constant will be function of x because v is a function of x and y both. Here we are only integrating with respect to y, so the constant term what we will get will be function of x. Therefore, from here we can write v is equal to y square plus f of x. Let this be equation number 1. Now, using second Cauchy-Riemann equation, again we will differentiate this u with respect to y. Now, differentiating this with respect to y, we get 2x is equal to negative dou v by dou x. So from here, if we integrated both sides, we can write integral dv is equal to negative integral 2x into dx. Therefore, from here v will be equal to minus 2x square by 2 plus a constant which will be a function of y. Okay, so v will be equal to negative x square plus f of y. Now, if we compare equation number 1 and equation number 2, we can write v is equal to y square minus x square plus some constant. Okay, because f is a function of y and in the first equation f is a function of x. So if we compare, we are getting this, and there will be some other constant to satisfy this equation. Now let's get back to the problem. So the correct option here is option A. Okay. For more information, you can refer to the NPTEL course, lecture number 1, Analytic Functions of a Complex Variable, on Mathematical Physics by Professor V. Balakrishnan of the Department of Physics at IIT Madras.